Hello guys, this is Vierra from Vierra Manufacturing Services. Welcome back to my C tutorial. In this tutorial, we are going to be generating the M&G code required for VMS project 3. So let's get started. So guys, in the previous project, we spoke about face operation, profile operation, pocket operation, and even drilling operation, right? So these are, this threading operation, quantum 3D, these are equally 2.5D or 2D tool paths. So we are going to see this thing with, all this particular operation with time. So I want to introduce you guys to another 2.5D operation. It's known as 2D Imachining. So just as a summary, 2D Imachining is actually an operation which is actually used to machine pockets, right? We have already a pocket operation, right? But 2D Imachining machines pocket more rapidly as compared to a simple pocket operation. So it's only used for pocketing, but it's more efficient. Okay, so let's get started. New milling operation, save. So this is let's say VMS project 3. Okay, good. VMS project 3. So okay, fine. It's going a little bit slow. Okay, internal. So I'm good with the name VMS project 3 milling. I'm just good with the name. Okay, let's take external. So unit, I'm gonna be using unit in millimeter. No, it's inches, right? Yeah, inches, fine. So internal. Okay. So CNC machine, I'm using G-milling 3X coordinate system. Select face. I'm selecting this top face. Okay, all good. Okay. Stock definition. So this actually, it's very clear. We are going to be using a box absolute coordinate. So we are using a raw material as a rectangular block. So take model dimension. Okay, it sticks perfectly. Good. Okay. So program number. This is our program number 3. So as you remember in the previous tutorial, we just end here, right? We define coordinate system, stock, target, and program number. That's it. We just end here and we just press OK. So one thing for iMachinery is you have actually to add data for iMachinery. So just come over here, iMachinery data. So okay, just put this down. So iMachinery database. So just choose this. Okay, material database. I'm gonna be using. Remember we are. Let me just use. I'm just checking for aluminium. Let's see if we can see aluminium over here. Otherwise, we are going to be using steel. Okay, let's just take free machinery steel 180. Okay, good. Machine level, it should be at 3. Okay, good. Okay, fine. Take some time. Okay, all good. So as you may notice, first operation be done is face operation. So I go face. Okay, geometry stem tool. Okay, I'm gonna be using face mill. My tool holder already on. Okay, I'm gonna be using a face mill of 2 inch. I'm gonna increase the length to 5. Okay. Levels. Upper level 0. First depth. Let me just take 0.01, let's say. equals step down of 0.04. Technology, I'm going to be using hash 50% tool. I'm going to complete set. Okay, tool equally, and before I forget, coolant should be on. Okay, perfect. Technology of fine. Let's just put this automatic. Link none. Okay, all fine. Save, calculate, simulate. Okay, let me just drag this over here. Slowly verify. Play. Good. Perfect. Just forgot to show you guys the rest material. Okay, rest material. Okay, good. So one thing I'm gonna do right now is I'm gonna, machine this particular part using pocket operation, right? If we want to machine this part, we could use pocket operation as in the previous tutorial. But right now, what I'm gonna do is I'm gonna use 2D Imachining to machine it. As I later on said, with 2D Imachining, we have a better finishing, surface finishing, and a higher efficiency. Okay, guys. So it's actually a great improvement in SolidCam. Okay, good. Click on 2D Imachining. Let's look at this geometry. So just come over here, feature recognition. So this one is when if you use this, it means you are selecting the face. For example, okay, this selected. Click here to begin. You just click. Okay, just push this over here. So I want to machine this part, right? So I'm going to use this face. Okay, just click it and it's selected. Okay, just unselect. Otherwise, you just use this place. So it's like the normal one. Okay, click here and then just select, the chin. Oh, perfect. Okay, all good. Okay, tool. One thing, just come over here. I roughing plus I finishing. Okay. Let's look at this tool. An end mill of say 0.5 inch, making sure the length should be at least 5. Okay. Coolant on. Okay, all fine. Technology. So one thing with machine level is the more the machine level, the more the machine is aggressive. So if you put it at 5, it's going to be less aggressive. So generally put it to be more aggressive for a better finishing. So come to modify cutting condition, take turbo mode. Okay, so as you notice, it increases the the cutting speed. Okay, fine. Technology. I'm gonna be using offset, just to make a roughing. So let's use 0.002. Okay, same thing for floor offset. Then I can't see. One thing I'll do is I'm gonna deselect this. I'm only going to be using a floor offset of 0.02 and then a finishing of 50%. Fine. You can on the compensation equally. Okay, good. Link. Okay, there's nothing actually to touch here. So guys, if you are using I roughing, it's simply going to rough without making a finishing, right? If you are using I roughing plus I finish, it's gonna make roughing and then finishing. So generally, if you use I roughing, then later on use I finishing. So IRS is actually when the tool is so big, right? So right now you are going to be using a smaller tool, and then you're going to use IRS like in the previous tutorial. Okay, fine. So save, calculate. Okay, simulate. Yes. Okay, so they verify. Let's look at this. Okay, to look at this, let me just increase the speed first. Okay, let's look. Okay, it's pretty fast. As you notice, it's even faster than a normal pocket operation. So as you notice, one thing is sure with iMachinery is when you are using iMachinery, higher efficiency, higher surface finishing, and again, you move at a higher speed. rest material. Let's look at this. Oh, perfect. So you notice that this part isn't done properly. It means the tool is too big, so we have to use a smaller tool, and this time we are going to be using I rest. Let's look at this. So just our trick, save and copy. Okay, so it copies the iMachinery data. It's taking some time. Okay, good. So just change this to I rest. Again, make sure to change the tool, select another tool. Now an end mill again, but this time, yeah, 0.25 is just perfect. Making sure to increase the length to, let's say, 5 to avoid collision. Okay, coolant should be on too. Oh, fine. I think it's pretty good. Levels stay same. Okay, I can just increase aggressiveness and activities. Technology, oh fine, it's rest, right? Okay, I think it's fine, it's not bad. Link, oh fine, oh fine. Okay, save, calculate. Okay, simulate. Okay, fine. Select, verify. Okay, let's look at this. Let's slow down speed, simulate. Okay, good. So it's trying to go deep, but it still looks like this tool is big. I don't know if I should use a more smaller tool. Let's look at that. Let's just wait for it. Let me just increase speed. As material. Okay, the tool isn't small, it's just perfect. It's just nice, guys. So now we are going to machine this outer portion. You could use pocket operation, or again you could use 2D iMachinery. So I'm gonna be using 2D iMachinery again. So one thing I'm gonna do is, again, the same thing, save and copy. Okay, so this save copy enables you, to be more fast actually, rather of repeating the step over and over. So I'm gonna be using iRough plus iFinish. Geometry, you change the geometry, so this becomes your new geometry, this side. Okay, just perfect. This is your new geometry. Okay. Okay, good. Tool. I'm just fine with this tool. I hope it's going to be okay. Yeah, I think it's going to be okay. I'm fine with 0.25 inch. So this is tool number 3, right? Making sure the coolant should be on, all good. Levels, upper level is at this point, fine. Lower level is at this point. Okay, oh, perfect. Okay, good. Technology at a high level. Turbine on, or fine. Technology. Okay, I'm gonna take finishing, and then I'm gonna finish the surface over here. Link, good. Control. Okay, oh fine. Let's try this. Save, copy. Sorry, save, calculate. It's taking some time. Simulate. Yes. Okay, let's look at this. Just slow the speed. Oh, there's something wrong. Something wrong. Our geometry isn't correctly selected. Let's look at this. Show geometry. So what happened as geometry is selected? Okay, one thing I'm gonna do is I'm gonna off this and this so I can better view it. Okay, let me just put this down. Okay, let's just select it back. Okay, right now what I'm gonna do is I'm gonna go over here. I'll click here and then select this face. Okay, it's fine. Okay, take tool. My tool is okay, I think so. Levels, okay, fine. Just select back the level from this point to this point here. Okay, I think it's fine. Okay, aggressiveness, fine. Oh, fine. Let's check this. Don't know what actually went wrong. So let me verify. Okay, just perfect, right? I think we did a mistake, but I can identify which mistake we did, because the tool was actually going around as if it was a profile operation. But anyway, I'm good. I'm pretty fine. We succeeded. Okay, rest material. Okay, just perfect. That tool was actually just perfect. No rest point, all just done perfectly. Okay. So let's look at what next. So what next is we are going to be using drilling operation. Okay, good. So now we learn about drilling operation, right? Now I want to teach you guys about drill recognition. Let's click on drill recognition. It's equally used for making holes. Now there's just one similar difference. So click on new. Oh, it takes some time, computer is slow. So one thing I'm gonna do here is let's click find hole. You see, when I just click auto and I click find hole, it detects all the holes on the part. It detects all the holes totally on the part. So one thing I can do here is like, let me just find show hole. For example, if I click on this hole, oh, it takes time. Show hole. Okay, so it will show you exactly, you know, the depth of the hole, the upper hole, you know, everything about the hole is going to show you everything totally. Okay, so let me just start back the process. Just come over here after clicking on drill recognition operation. Just come over here, click on find hole. Okay, perfect. It detects all the hole. If there is a hole, you know, maybe because when you click on find hole, it's going to find all the hole, you know, on the part totally. Even the holes under here, it's going to detect it. So surely you have to come over here and, you know, unselect the one you don't want, like remove hole. Hope you got that. Okay, click on OK. Fine. Tool. There's something I need to know, you know, it's diameter equally. It's spark 3. I'm fine with spark 3. Okay, just push this down, go to evaluate, measure, just measure this diameter. It's 0.16, so I'm going to be using 0.16. Fine. I'll increase the length to 5. Okay. Oh, good. Okay, let's look at this. Coolant should be on, especially for, you know, drilling operation, tapping operation, and even cut off operation, and even engraving operation. Coolant should always be us. Okay, I'm gonna edit this. You see, depth edit. You see, one thing about drilling operation you guys should understand is when you use drilling operation, right, it selects the upper level and again the drilling depth for you automatically. When I come to depth edit, as you notice, upper level is at 0 and then the drilling depth is at 0.628. It selects all for you automatically. So this one you don't even have to touch it anymore. Technology, I'm going to be using the cycle, automatic cycle. Okay, oh fine. Drill. Let's look at this. So let's verify. Okay. Drill. Let's look. Perfect. It's very fast. Rest material. Good. So the hole has been done, but it seems it hasn't been done fully. Seems to be some issue over here. Yeah, it has not gone that deep. Okay, so there's an issue over the depth. So one thing I'm gonna do is, let's just come to levels, right? Depth edit. So this is the depth. All, click on this, or apply. Let's look at this. Okay, save, calculate, simulate. So let's verify. Don't know if this will change the fact. No, I don't know what's the issue. I don't know what's the issue right now. It's 0.6. Okay. Now kindly come and click on full diameter. This is very important, guys. Click on full diameter. Do not edit the depth, but rather click on full diameter, and again apply. Okay, I'm very sorry I didn't see that. Okay, fine. So verify. Okay, I think this should be good. Okay, full. Oh, perfect. So sorry for that mistake, guys. It's actually, I'm very sorry over that. Okay, so now we have some, chamfers. So I don't know, should I give you guys this chamfer for assignment? I think we are done, guys. I think we are actually done. You guys can actually do this chamfering for assignment. But anyway, let's look at this rapidly. Okay, so we have to put, chamfer outside here. Okay, one thing I'm gonna do is I just come over here, coordinate system. Yeah, it's coordinate system. Just open coordinate system, add. Yeah, surface. Okay, I choose this, so I'm defining a new offset. Okay, good. Okay, fine, good, define. So next thing, so now it's your wish, right? Like, it's either we are using pocket. Okay, in last tutorial we spoke about edge debugging, right? So in this tutorial, let me just use, I'm gonna use profile to make chamfer, right? Last tutorial we used edge debugging for chamfer operation. So right now I'm gonna use profile to show you guys how we make chamfer using profile operation. Okay, select the chamfer. So we select the external part. Think this part. Okay, is this fine even? So tool, let's look at this tool. Let's just put this. Okay, so I'm gonna be using a chamfer tool, chamfer mill. Good. I'm just good with this default. I'm just going to edit this length. Okay, making sure the colon is on. Fine. Levels, I'm just gonna give 0.001. Okay, technology. So as you know, remember when we are using profile operation, we always keep this technology as known, right? Now if we want to machine an external portion of the part using a smaller tool, we use rest. Okay, but right now we want to machine chamfer, so we are going to use chamfer. Now I'm going to reduce this to this level. Okay, fine, it's just perfect. Just come over here, technology, finish is totally fine, no need to turn around. Step down, I'm going to use this step down. Why not? I can just put some roughing equally. Okay, let's look at this. Sorry over that. Okay, just perfect. Maximum step down of this. Okay, we are done here. Check the geometry, very important. Okay, let me just turn this over here. So this is the two part, so I can just take right. Okay, I think right is fine. Okay, link. Okay, I will take normal of 0.01. Okay, fine. Okay, let's try this. Save, calculate, simulate. So we verify. Oh, we did one crazy error. I was doing this mistake. Oh my god. Yeah, select Mark 2, guys. Mark 2, we always do this mistake. Oh my god. This is just a crazy mistake. Okay. Okay, taking this. Okay, let's just go a little bit fast. Two levels of fine technology of fine. Let me check this. Okay, let's go back left. Okay, I think we are good to go. Okay, simulate, solely verify. Okay, just perfect. As you notice, guys, the chamfer has been done. Rest material, all perfect. So guys, this is the way you can make chamfering using the profile operation. So basically, I know you guys will say, oh, I would prefer to use edge debugging, right? But I just want to show you guys that you guys can equally do chamfering using pocket operation. So guys, hope you like this tutorial, guys. This is the VMS project for completed, guys. Let's look at the M&G code generation. So over here, operation, let's close this first. Okay, let's look at this. Generate our code, fine. Okay, it's taking some time. So we are soon going to have our M&G code generated in our Simco editor. So you should equally know, guys, this Simco editor is not a simple editor. We could equally generate the M&G code, say in a notepad file, right? Notepad, or maybe in an Excel sheet equally. However, we are generating it in a Simco edit. So as times go by, I'm gonna be teaching you guys about Simco edit. What is the use of Simco edit? Why does it exist? So kindly keep following my tutorials, guys. Kindly keep sharing, guys. Comment so that you know I can improve. So we are going to be working together. So I hope you guys are excited. In the next tutorial, we are going to be making another basic part where I expect us to be using new operations such like drilling operation and even slot operation. So guys, I hope you guys are excited over the next tutorial. Kindly, guys, like my video, share and subscribe. Keep motivating us so that we can grow. I love you all. Thank you so much.